Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we'd like to thank you for attending today's presentation on why manufacturers use new flame treating technologies to improve surface adhesion. Please note that this webinar is being recorded, and you will be able to access both the recording and the presentation slides once they are available online, usually within 24 hours. If you have any questions during the webinar, please use the GoToWebinar question tool. You may submit a question at any time during the webinar. We'll reserve time at the end to answer as many questions as we can. For those of you not familiar with Enercon Industries, Enercon's a global supplier of innovative surface treating technologies, including flame, atmospheric plasma, and corona. These technologies are designed to improve adhesion of adhesives, inks, paints, and coatings. In today's presentation, we will explore why inline surface pretreatment is needed, the benefits of using flame treating, what industries use flame treating, how flame is created, and how it modifies surfaces to improve adhesion. We'll look at how combustion control technology and burner design contribute to repeatable results. We'll look at the design features which make flame treaters very safe to use. We'll explore numerous application examples, and we'll also introduce you to Enercon's newest flame technology. And again, at the end, you'll have a chance to have your questions answered at the end of the webinar. Today's presenter is Wilson Lee, Enercon's Business Development Director. Wilson has extensive experience in surface treating applications over a wide variety of industries. Wilson works with Enercon customers on developing flame and plasma technology solutions to solve their surface treating challenges. Wilson earned an electrical engineering degree and an MBA from Clemson University. With that, I'll turn the presentation over to Wilson.
All right, thank you for coming. We're going to start by going through, a lot of times when you talk about surface energy, you talk about terms like hydrophobic and hydrophilic. So let's go over those real quick so that we understand what we have. A hydrophobic surface is a surface that's very difficult to bond to. Plastics, as the example here shows, generally has a relatively low surface energy. Other things that might contribute to a hydrophobic surface are additives that may be flame retardants or different temperature additives that are in plastics. You may have surface contamination. All of these things lead to limited bonding sites and give you a very hydrophobic surface. Cohesion versus adhesion. When you look at, in this case, liquid sitting on the surface, you have two different forces that are important to whether or not you're going to have a good bond. You have the adhesion forces, that's the force between the surface and, again, in this case, the liquid, maybe it's a paint, maybe it's an adhesive. You also have the cohesive forces between the molecules of these, whatever is on the surface, in this case, liquid again. If the cohesive forces are stronger than the adhesive forces, you're going to have a very hydrophobic surface. If the adhesive forces are stronger than the cohesive forces or cohesion forces on the surface, then you're going to have a very hydrophilic surface, which is what you're looking for when you want to bond. So now we go back to the same slide that we had a minute ago, and we show a hydrophilic surface. You've got a much higher surface energy. Hopefully you removed all the surface contamination, and any migrative additives that were on the surface have been removed. This increased the number of bonding sites and again gives you a much better surface with which to bond to. So why flame? I take a lot of calls about new applications, usually on a daily basis, and we start looking at what might be the best technology for your application, whether it's plasma, whether it's a blown ion or a blown arc, might be corona. But many times flame turns out to be the best for any application, and these are some of the factors that we look at. Number one might be economics. If you're looking at a larger system, it just usually is more economical to buy a flame system to treat the part versus a number of plasma systems or a number of blown arc systems. So economics gets in there quite often. Flame is a very quick treatment device, so you can go very fast. We usually start at about 75 feet per minute and go up from there. So if you have a larger surface, you might need to go again with flame. Complex geometries is also something that we have to look at. The dashboard that you see in the picture has a lot of concave and convex sections to that, and it's just easier to treat those with flame than it is with plasma. Plasma, generally, you have to be relatively close to the surface, and that distance from the surface needs to be very closely regulated. You have a little more flexibility with flame to treat larger, more complex geometries. Again, the size of the area comes into play back with all of those three things above it, the economics, the speed, and the geometries. If you have a very large area with all of those things, flame typically is the best way to go. And then you have surface chemistry. There are a lot of materials that don't really care if you treat it with flame or plasma. They'll both respond or treat the process or treat the surface very nicely. But there are certain materials out there that just prefer flame or plasma, and so sometimes that comes into play. So where's flame used? Just about every industry that you can think of. The main industries we deal with: aerospace, automotive, multiple consumer goods, electronics, medical, packaging, window and door, wire and cable. And the basic applications are the same that we deal with on all of our technologies: or bonding, assembly, coating, deburring, I should say, decorating, painting, and printing. Here's a few of our automotive examples as far as applications where you use flame. Again, in many of these, you see that you're dealing with a three-dimensional part that would be a little bit more complicated to treat with maybe flame, a blown ion or a blown arc. So it's just easier for us to do this with flame. It fits the application better. It's an easier way to say that. Common automotive applications. I won't read the whole list here, but you can see them. Headlamp films, glass lamination, trim, a lot of painting applications, airbag, adhesion, gaskets, some dashboards, wire and cable. Generally, it's not marking. We should have changed that. Generally, with wire and cable, it is different layers that you're putting in the wire and cable. Marking a lot of the time is done with plasma, but still, we do a lot of wire and cable applications with flame. Now we're going to show a quick video of some flame treatment, and we won't be able to hear any sound as we go through here from us, so we'll be back on in just a minute. What you saw there in the video, of course, was what we were talking about earlier. You see larger parts, how quickly those can be treated. You also were able to see the different contours that flame allows you to treat seamlessly. So you're able to get a good treatment on multiple levels of the surface, and you don't have to be quite as accurate with the distance as you are from the system. This slide shows some normal parts that you'll see that we treat with flame. You'll see the initial dyne there in the third column, usually in the low 30s, and then you'll see the dyne level after treatment. Now the range is because of how we treat the part and the speed that we're going. So in almost any treatment that you do, whether it's plasma or flame, the speed and the distance from the part is the important thing, and that's going to affect the dyne level. So say with ABS, you're going to start in the low 30s, but depending on the treatment speed and distance, you can be anywhere between 50 and 72 dyne once you've finished the treatment. And what we do is we look at your specific application. So if you need to be at 60 dyne, we just go a little bit slower. We change the flame a little bit, or we can decrease the distance from the surface. And all of those things will increase your dyne level. So the first thing we'll do is we'll test your application, come up with whatever level of dyne that you'll need to be successful, build in, of course, a safety factor, and then we'll treat that and make sure that we're using the right speed and distance to get you to the correct dyne level. So how do flames work? A flame plasma is just an ionization of a gas mixture, usually natural gas or propane. It's formed when the flammable gas and air mixture are combined, and then you'll see the intense blue flame that shows that you're getting a good treatment, or that you'll get good treatment out of that flame. The surface of the materials are made polar as species in the flame, and plasma affect the electron distribution. That's a fancy way of saying that we're adding polar groups to the surface. Now, those polar groups are generally hydroxyl groups, carbonyl groups, or carboxyl groups, and all of these will increase the polar surface so that you can bond to. Generally, when you have a surface that's not easy to bond to, it's because you don't have very many polar species on that surface. So we're increasing the polar species, and that is what's allowing you to get a good bond. Combustion control. There's multiple ways to control the flame. We have manual systems. We also have closed-loop systems that are more precise. But what this is allowing you to do is control the flame in certain ways. Depending on how precise your particular application needs to be, we might choose one of these versions over another. But generally speaking, we're going to build in a safety factor so that you're not close. Again, going back to the original example, if you needed to be at 50 dyne, we would treat your surface to something closer to 60 dyne so that you would make sure that you're getting consistent treatment every time. So which one of those is the best system? Well, again, it depends on your application. What are the variables associated with your application, the level of treatment that you need required, what is your budget? All of those things would be considered before we choose which flame system would be best for your application. Our burners. We use a drill port burner, and these are high velocity ports. We have different burner designs for different applications, whether it's going to be a stationary burner, say over a conveyor, or if we're going to put a burner on a robot. There are different applications and different burners for each of those. We prefer the drill port burners because we can eliminate laning. You've got a variable treatment width, so we can go pretty much as wide as you want to go, and there's safety features that are built into our burners to monitor whether or not there's actually flame coming out. So what are those safety features? We have numerous designs that will keep these safe. One of the things that we hear about from certain people is that they don't want flame on their floor, that they don't recognize the safety features that we have. We have these fail-safe designs so that anything that happens and anything that we're monitoring, if one of those things goes wrong, the gas flow ceases immediately. To do this, we have redundant solenoid valves. So again, if one of the valves goes out, we have another valve there ready to, again, reduce the flame and turn off the gas. We have safety relays that monitor the presence and controls redundant safety solenoids, so make sure again that both of those things are working. We have a flame detection electrode. The portion of the flame head that actually ignites the electrode once the flame is going, there's a small voltage there that is detecting, and as soon as that voltage goes away, it knows that the flame is no longer there, again shutting down the gas so that you don't have gas running through the system. The air line continues to flow to make sure that you're purging that system. We have backflow prevention so that obviously you don't want to have the flame, the gas going back into the system, so again it's purged with the air flowing through the system. And then we have pressure switches. All of these things are designed to make sure that if something happens, there is no gas continuing to flow through the system. Different types of integrations are shown here. Many times you'll just use a static flame system so that you just have it over a conveyor or something and something is going to run underneath it. When you're dealing with automotive type applications, generally it's going to be on a cell and you're going to have some sort of 3 or 6 axis robot controlling the flame and moving it around and trying to treat the surface. And again, you can't do that with on a conveyor system, so you use a robot. All right, some of the applications. Interior panel decorating. Generally, this is a polypropylene. Occasionally, it's a fiberglass. Both are easily treatable with flame. You can do this in a few seconds. Generally, the cycle time in something like this is less than 45 seconds to treat the part. This is a note from a customer of ours who wanted to make sure that we understood how well this was working for him. He had a 10-second cycle time with this. The robot had a very close tolerance so that we were able to get consistent treatment over that area. Again, once you control the speed and the distance from the part, the more consistent the treatment is going to be. Dashboard wrapping and foaming. Again, these sometimes an EVA dashboard is a good application for flame. Again, you can see the dashboard on the side over there before it has been coated. It's got a lot of different portions to it, a lot of different concave, convex, and areas that have to be treated. And again, flame allows us to get into those and get a good consistent treatment, even though you're dealing with a very complex part. Window and doors. Again, in this one we started with initial dyne of less than 30. We were able to treat the PVC for the door frame and get it above a 58. Again, this would be a difficult application to do with plasma just because of the different areas of the door that are more difficult to get to, so it's easier to do this with a flame treatment. Again, a bonding application if you're going to put a skin on the door. In this particular case, we started with a relatively low dyne of 40 and got a much higher dyne level, so you're going to get a consistent coating onto the door frame, or the door itself, I should say. Veneers that are applied to a PVC door. PVC is a very low dyne in its natural state. It's usually about 30. So once we treated it, we got it above 60 dyne, and then we were able to add the wood veneer to the door, and it stayed. Again, you get a good consistent bond over the entire surface. If you're filling pretty much anything that's foam filled, you can pre-treat the area on the inside before it is filled with foam so that you can get a good consistent coating on the inside. And this could be a window and door application, it could be an appliance application, almost anything, boats, other things that are filled with this foam, you get a better treatment on the inside, or you get a better coverage on the inside once you've flame treated the material. And this is our new Flame Series Pro. It has a touchscreen interface. You can switch between natural gas and propane from this screen, and it's a very simple application. There's no valves or anything that need to be turned. It's all manually controlled there. You have real-time gas and airflow monitoring. No calibration is required. It has Ethernet capability, USB troubleshooting. We can do this in single and double heads, and it comes in multiple power levels depending on the size burner that you need.
All right, thank you, Wilson. And before we jump into your questions, we're going to put a poll out to you to get some of your feedback. I'm going to launch that poll momentarily here. Looks like we got about half of the responses in so far. We'll leave this open for a few more seconds, and then we'll get to your questions. And we'll go ahead and close the poll. All right, so now we'll take a look and see if our audience has any questions. Okay, looks like someone was hearing some echo. Is it possible to inject chemicals with the flame?
Okay. I'm not sure I understand what we're after here. I might refer to Dave on this. Dave Habel is in the room with us, and he may be able to answer this question.
There are some flame systems that are designed to inject a chemical, generally some form of like a silicone or something, into the flame that kind of does a deposition onto the surface as you're doing the treatment. That is not a style of treatment that we currently offer, but it is something that we would be willing to look into, depending on what your application is.
All right, thanks, Dave. Next question is about how long can you expect the treatment to last after it hits the surface?
This is going to be very surface dependent. We should have put a slide in here that we use in a lot of our other webinars that shows the basic treatment cycle of any material. If you look at it from a dyeing perspective, you start at a low dyeing. Right after you treat it, it's going to jump up to whatever the dyeing level was, similar to that chart that you saw. And then it's going to steady state for a time that is very dependent on the material itself. Some materials are very stable. Carbon fiber is one that I can think of that's generally very stable. Glass is pretty stable. Many metals are stable, and that means that they'll last maybe 24, 48, 72 hours, even weeks or months. Some plastics are not very stable, and they'll only last a few minutes or even a few seconds. So each material is different. The best thing to do is to contact us. You can send the material to our lab. We can do a time survey on your material and give you an idea of how long you have before the next process step. But it's generally best practice to treat the material immediately before you bond it or coat it or paint it or print on it.
Okay, the next question is flame use in flexible packaging? When we're looking at rolled goods, Enercon does have flame technology for those applications. When you're looking at printing applications, it's normally a corona treater that's used. Atmospheric plasma can also be used. We do see flame used on extrusion coating applications, burning off fibers of paperboard. Those lines are obviously very high speed, and flame is very effective for those processes. Can you give the difference in flame treatment ratios of air propane as opposed to oxygen propane?
I'm going to refer to Dave again, let him answer that question. I mean, generally, if you're running a air propane mixture, you're running about a 23-to-1 air to propane ratio. We do not sell oxygen style flame systems. It's not our specialty. It's a different kind of burner design. I really can't speak to what the ratio of a oxygen propane mixture ratio would be. By using an oxygen, you do get a hotter discharge. That's generally the better effect you get, is just a higher temperature flame than you would from a air-based flame.
Dave, this question is similar. Do you gain better process control if you use propane gas instead of natural gas? And is there a standard air-gas mix ratio you start with?
Again, for a propane flame, we would run about a 23-to-1 ratio. For natural gas, we're running 10-to-1. From my experience, I've never seen a significant difference in treatment results when using natural gas or propane.
Can we speak towards an average increase of dyeing on a powdered surface?
You're going to increase the dyeing, but again, every surface is, unfortunately, I know it's not to be a satisfying answer, but I can't give you a range. And again, I could change the delta that you see there by just changing the treatment duration and the distance from the duration. So yes, we can treat those surfaces, but it just depends on, again, the method at which we treat it and how quickly we treat it. It's going to give you a different level and a different range of that dyeing. So again, the best thing to do is to probably send us some of your material, and we can give you that range. We can tell you at what speed and what distance we treated at and what level that came to, and then we can play with it a little bit and give you the range in which you need, and then we can just figure out what level of bonding you need. Or at least what dyeing level we need to get the bond that you're looking for.
All right. Have you seen any applications in the bonding of aerospace composites? And I know, Wilson, you've done some work in this area with plasma as well.
Yeah, aerospace composites, there's a lot of hand prep that's involved with that. There are methods that we have been using, and we're working with a number of manufacturers to reduce the hand prep time. We've done it a lot with with plasma. We've done it a few times with flame. But yeah, there are definitely some pre-treatment steps and some ways to decrease the cycle time to prep a part for composite bonding.
Wilson, could you talk about smaller plasma units, including the possibility of handheld plasma units?
We do not offer, we do have smaller units, but we do not offer handheld units just because of the safety issue that we have there.
What is the durability of the chemical functions that are created in humidity tests?
I'm going to have to see if anyone else in the room can answer that question for us. I do not know the answer to that question. So if you will contact me, send me an email, I will look into that and we'll try to come up with an answer for you. I apologize, I do not know that off the top of my head.
Can you apply treatment more than once at a time to get a better dye level before adhesion?
Yes and no. You can slow down the treatment, you can treat it more than once, but you're going to get a diminishing return. There is a level at which you're not going to increase the surface energy on any surface. So you just need to make sure that we're treating it to the point that gives you the coating or the surface that you need for whatever your next step is.
Is the in-house laboratory testing that we provide free?
It is free. So just, again, contact me, contact one of the regional managers, and we will give you an RMA and bring in the material. And we run multiple tests a week, and so we're usually pretty quick at getting the results back to you.
Do you require liquid to cool the system?
Once you get above a certain width, what is that width? 16?
Once you get over 400 millimeter on a burner width, we then proceed to go to a water-cooled burner. Otherwise, there is no liquid to cool the system.
Can you talk a little bit about the parameters again that you can do to optimize the treatment distance range from the flame, for example?
So in general, when you're treating with the flame, you have control over your gap from the burner head to the substrates, generally running between about a 1 to 4 inch gap. So you have control over that. You have control over the speed that you're processing the system. You're moving the burner across the system. You have control over the outputs of the flame system, basically the amount of air and gas you're putting out to the system. So there's several variables that you can control to try to adjust based off of the parameters that you're trying to run.
All right. Is there a chart showing how long treatments will last per material type?
Unfortunately not, and the reason is just because of the number of variables involved are so great that there would be just too many of them. It's just easier to take your material and test it and get an idea of what the curve is going to look like. Because even the same material from two different manufacturers are going to have slightly different properties. So there's just too many variables to keep in there. I mean, all the curves look the same. Again, you're going to treat it. You're going to see an increase for a specific amount of time. Then you're going to start to decrease. You generally never get back to where you started. But again, each curve is going to be different, and that would vary. Again, I could have PVC made from two different manufacturers that would have a slightly different curve.
Is exhaust required for flame systems?
We always recommend that you would exhaust any of our systems. For one, there's heat generated when you're dealing with the flame system, but then there's also any kind of contaminants that may be flashed off of the surface. We can't guarantee what would be coming off of that surface during treatment, so we would always recommend that you exhaust.
All right, thanks, Dave, and thanks to our audience. We appreciate your time today and your questions. Again, you can follow up with Wilson if you have any additional questions. That will conclude today's webinar, and we appreciate your time once again.